Hi Professor Chen, this is my first video of HW10 and this video is about question 1. And the question is, collect the definition and the simple property of example of stochastic process. The first is Poisson process. And we define the Poisson process like this. The x0 is equal to 0 and xt1 minus xt2 equal to the number of calls received in the interval between t2 to t1. And let t equal to t1 minus t2. The probability xt1 minus xt2 is equal to k, and this probability equal to this. We can know that the Poisson process is derived from the Poisson distribution. But the difference between these two is the Poisson process is a process with interval is dynamic, but the Poisson distribution is with the fixed interval. And Poisson process interval is dependent on the time, dependent on t. So which means the parameter of Poisson process is equal to lambda t. And we know that lambda t is a function of time, so this is the stochastic process, is not the distribution. But the Poisson distribution with the parameter equal to lambda, where lambda is equal it's a constant. So the difference between these two is this. So based on what we have calculated in the previous homework, the mean of the Poisson process is equal to lambda t, and the autocorrelation of Poisson process look like this. And the second one is Poisson increment. Poisson increment is based on the Poisson process, and we know that the xt is a Poisson process, and we gave a constant epsilon, where epsilon is greater than 0, and we can construct this process like this: yt equal to xt plus epsilon, then minus xt, then divided by epsilon. So the yt is a Poisson increment process, and the mean of this process is equal to lambda, and autocorrelation of this process is look like this, which we discussed in two different circumstances here. And third one is Poisson impulse process. And the Poisson impulse process, just like its name, we can view it as a series impulse signal here. And this process is derived from the previous two different circumstances. The zt equal to differentiate of xt of t, and zt also equal to the limitation of yt, where epsilon is 10 to 0, and the mean of this process is equal to lambda, and the autocorrelation of this Poisson impulse process it will look like this. And the fourth one is semi-random telegraph signal. The stochastic process is defined. This stochastic process is defined as follows, like this: the xt equal to 1 when k is an even number, and the xt equal to minus 1 when k is odd. So the probability of xt equal to 1 is equal to the k is even in the interval between 0 to t. And the semi-random telegraph signal is also based on the Poisson process. So in order to calculate the probability of this circumstance, we can just add the different the probability of different circumstances here when k is even. So the probability xt equal to 1 is equal to this. And the mean of this process is equal to e to the minus 2 lambda t, and autocorrelation of this process is look like this. And the fifth one is random telegraph signal process, which is different from the semi-random telegraph signal. And in semi-random telegraph signal, the x0 is a fixed number. We know that the xt equal to 1 when k is even, 0 is even, so the x0 is 1, it's fixed. But the random telegraph signal process is based on, is depend on a random variable we define as a, which means the the x0 is not fixed one. It can be 1 or -1, which depend on the random variable of a. And the probability of a equal to 1 is equal to probability a equal to -1 is equal to this. And we can construct this new stochastic process yt equal to a multiplied by the xt. So the yt is the random telegraph signal process. And the mean of this process is 0, and the odd correlation of this process is look like the semi-random telegraph signal, the previous one. It's also look like this. And the sixth one is really interesting because this is widely used in different subjects, such as biology, chemistry, physics, and also economics. And the random walk can be viewed as a kind of ideal mod of Brownian motion, which is term of physics. And we define this. We describe the random walk process with this kind of statement. Toss a fair coin n times, and k is the number of heads in n toss. So the probability xt equal to xnt equal to rs, where s should be a constant. It's equal to like this. For t, t located the range between nt to n plus 1t. And the mean of this process is equal to 1, and the odd correlation of this process is equal to this. And in order to understand this random walk process, we can just think about the elementary example of a random walk, which is the random walk on the integral number line, which starts at 0 and at each steps moves 1 or -1 with equal probability, which look like a drunk people walk around the street. So this is a random walk, which is really essential. And the Wiener process is based on the random walk process, and we define the Wt equal to the limitation of xt, where xt is a process of random walk. And when t tends to 0 and s square divided by t tend to a constant alpha, and n tend to infinity. And so the mean of this process is equal to 0, and odd correlation of this process is equal to the minimum value of t1 and t2, then multiply this constant alpha. So that's all. Thank you.